Ever wondered why enormous steel ships weighing thousands of tons don't sink in water? The answer lies in a principle formulated over 2,000 years ago by ancient Greek mathematician and physicist Archimedes. This principle, aptly named Archimedes' Principle, is a fundamental concept in fluid mechanics that governs the buoyancy of objects submerged in fluids. Today, we delve into the core of this principle and explore its real-world applications. To understand Archimedes' principle, imagine a rubber duck floating in a bathtub. The duck displaces a certain amount of water, creating a hole of sorts in the water. If you were to somehow weigh this hole, you would find that it weighs exactly the same as the duck. This is the essence of the Archimedes' principle. Any object, wholly or partially submerged in a fluid, is buoyed up by a force equal to the weight of the fluid displaced by the object. Now, let's break it down further. First, consider the object submerged in a fluid. It doesn't matter whether it's a rubber duck in a bathtub, a steel ship in the ocean, or even a helium balloon in the air. The principle applies to all these scenarios because, in physics, both liquids and gases are considered fluids. Next, think about the fluid displaced by the object. When the object is submerged, it pushes aside or displaces a certain volume of the fluid. This displaced fluid would have had a certain weight if it were still in place. The final piece of the puzzle is the buoyant force. This is the force that pushes up against the object, trying to buoy it or float it on the surface of the fluid. According to Archimedes' principle, this force is always equal to the weight of the displaced fluid. In summary, Archimedes' principle tells us that the buoyant force on an object submerged in a fluid is equal to the weight of the fluid that the object displaces. This principle has numerous applications in daily life and in various scientific and engineering fields. For instance, it's why ships float. A ship made of steel is much denser than water, and so you might think it would sink. But because of its hollow shape, it displaces a lot of water, which creates enough buoyant force to keep it afloat. In the medical field, Archimedes' principle is used in the design of the hydrometer, an instrument that measures the specific gravity or relative density of liquids. The operation of submarines, hot air balloons, and even the act of swimming are all governed by this principle. So the next time you see a giant ship floating effortlessly on the ocean, or a balloon soaring high in the sky, remember the ancient Greek scientist Archimedes and his principle of buoyancy. It's a simple yet powerful concept that forms the basis of many phenomena and technologies we see and use today.